Hello, my name is Mr. Rogers and you're watching the video lecture for Understanding Motion. We're in a brand new book. This is section 1-1, and you can tell, yes, I'm in my house. I'm hunkered down for our cold days here, so these notes are coming from my household. And so our objectives today, guys, you do not have to write these down, are to be able to describe how a reference point is used and to be able to calculate the speed of an object. Those two big ideas for the day. So first thing, in describing and measuring motion, is the idea of what is motion if something's in motion. Something is in motion when the distance from another object is changing. So to do that, we need a reference point. A reference point is a place or an object used for comparison to determine if something is in motion. So it's what you use for comparison. And the idea is that an object is in motion if it is changing position relative to a reference point. And so to illustrate this, we got a little visual. I found some pictures here for you. Got a tree on this side. Over here we have a Dodge Charger. I don't know why I chose a Dodge Charger, but I chose to. And so, like the notes just said, something is in motion if its position changes relative to a reference point. So as the car goes toward the tree, its distance between the tree and the car is changing. So that's how I can tell with my eyes that the object is in motion. I need that reference point, that frame of reference, you would say, to tell the object is in motion. Now, here on Earth, we are moving. We can't tell the Earth is spinning other than the sun, which makes it difficult to tell that we are actually in motion with the sun, compared to the sun. But again, the idea of a reference point, so the tree is our reference point. As the car gets closer, distance changes. We can tell the car has been in motion because that distance is changing to a reference point. So, when we understand how motion is compared to a reference point, we're going to be focusing on the idea of speed. And speed is distance divided by time, is the formula to calculate speed. So when you know both the speed and direction of an object's motion, you also know the object's velocity of the object. So velocity, simply put, is speed in a given direction. So if I'm traveling to Madison, I'm going 65 miles an hour north. At north, my velocity 65 miles an hour north. And so again, that big idea here also is speed. Speed equals distance divided by time. And I have a little trick to help you guys remember this and also use it to help you calculate not only speed, but also to find distance or time if you know two of the three. So here we have a triangle. We've used this triangle before. And in the middle we have speed equals distance divided by time. So S is for speed, D is for distance, T is for time. And I cover the one that I want to find. So if I want to find speed, I have my distance and time. So I just do the symbol, whatever it tells me to do. So distance divided by time would be what I would have to do to calculate the speed of that object. But with this triangle, what I can also do is, if I want to find how long it took the trip to take, I cover the T, and now it's D for distance divided by speed, and that would give me the time of the trip. And finally then for D for distance, if I cover that one, then I can see it's S times T, or speed times time, would give me the distance that I travel. So kind of a handy trick to help you remember how to calculate speed, but also, again, if you know two of the three, you can find that third variable. And finally here in our notes today is when we get to graphing speed after we can actually calculate it. So the steepness of the slope depends on how quickly or slowly the object is moving. The faster it moves, the steeper the slope. So time is shown on the x-axis and the distance is shown on the y-axis. So again, the big idea here is the steeper the graph, the faster the object is moving. So to see that real quick here in this picture, here's our graph, here's our x-axis, there's time, there's our y-axis, there's distance. So the steeper the graph, our red line here is steeper than our green line. So whatever this object was traveling faster than our green object because that graph is steeper, that line is steeper between the two. Alright guys, we're going to stop here today. I thank you guys for watching and we'll see you along the way.